Good morning and welcome to the 23rd annual exhibit of hydrogen and fuel cell technologies. Things are always changing in this market. There's always something new. Sometimes it's entire devices. Sometimes it's interesting tweaks to the existing technology that make new applications possible. So the potentials are always increasing. And I have a guest here to talk with me about one of the improvements, the potential improvements, which lead to new market chances for the solid oxide fuel cell systems. I'll be talking with Andreas Richter, who is Sales and Marketing Manager at CerPoTech. Please welcome with me Andreas Richter. Good morning.
Well, Brian, good morning.
So, of course, you've been here before, but as a general introduction, perhaps you could tell us about CerPoTech, where it's located, and a bit about the company history.
Absolutely. Good morning, everybody. CerPoTech, it's a Norwegian company. Just like my predecessor here, Björn, was representing Nel. We're part of the joint Norwegian booth here. Our company is based in the beautiful city of Trondheim in Norway. That's also where our roots are. We were founded by 3 professors of the Trondheim University. And that was almost 10 years ago. So we will have our 10th anniversary coming up later this fall. And as a technology company founded by professors, we started at the University Institute 2012. We raised capital and then established a pilot plant in Industrial Park in Trondheim. And that is a semi-industrial facility which we have been developing since then and which we use to supply our customers.
So this is the 3rd time you've been here. You were here last year and then the year before. If we go back to 2 years ago and look at the progress and the stages you've gone through, how would you describe them?
That is a very important question. How much time do you have today?
Well, we got 20 minutes, so let her rip.
Yes. That's good. No, since then we think we have come a long way. So 2 years ago, our focus was very much on R&D activities. And when I say R&D activities and markets, it is the production of small amounts of powder, very much on demand for a certain project, certain R&D activity. And that is a very good market still for us, also a very relevant market, because it enables R&D projects. However, based on that, we wanted to develop further and try to commercialize our company and the technology which we have in our company. So a step which we have taken 1 year ago, and I believe that was the topic of the talk here 1 year ago, was the establishment of, a bit reluctant to say mainstream ceramic powders, but maybe standard ceramic powders, state-of-the-art ceramic powders, which we started to produce in somewhat larger quantities, also on a continuous basis, and even made them accessible for our customers through a web shop. So it's really a win-win situation where our customers have easy access, shorter delivery, constant quality of state-of-the-art materials, and for us it's a very good chance to upscale production.
Mm-hmm. Solid oxide fuel cell systems, of course, are very complicated. We're referring to the ceramic aspect of that equation, but people are always when they discuss the solid oxide fuel cell systems, they're worried about durability, cost factors, it may be assembly aspects that you're facing here. You offer a specific technology that improves or allows for new, now here I'm getting into the technical side where you're more versed, but it allows for specific applications, specific temperatures, operating temperatures, and the vocabulary you use to describe that is very complicated. It gets into stoichiometry and so on, but perhaps you could indicate what technologically is involved in the powders you develop and how they're applied.
That is a very relevant topic which we also discuss a lot with our customers and partners. Because what we do, we enable developments and we enable products that then have long durability, that have good performance. So it is not the only parameter, but when you try to relate the performance, the durability, the startup time, some aspects of the production of an SOFC system, you can relate many of those back even to the parameters of the powder. So, for example, durability, that is very much related to how a cell degrades. And one of the reasons for cell degradation can be deactivation of the catalytic spots, you could call them, in the cell. And that happens more rapidly when you use a powder which is not completely homogeneous. Mm-hmm. So our production route allows us to produce powders which are almost perfectly homogeneous. Mm-hmm. So that is one of the core advantages of spray pyrolysis, and which makes this synthesis technology, production technology for ceramic powders very relevant for such sophisticated applications as solid oxide fuel cells.
Okay, so we have homogeneity. I'm always looking for the simple explanation of the spin-off effects. If we're talking about stationary applications, the big issue that people face there is the durability, not the energy density issue.
Yes.
If you have a mobile application, you're worried about how many kilowatt hours you're going to get out of a device this size or potentially smaller, and you really care about weight and size. Does your technology affect both of those equations potentially? Does it affect any of the other aspects, for instance, operating temperatures, so that the device becomes itself more flexible for commercialization?
Absolutely, absolutely. Now, one example which comes to my mind are, you mentioned mobile applications, auxiliary power units, small diesel generators. For those devices, the startup time is a very relevant parameter, because it's maybe not operated continuously, but you want it to go up and down and switch it off at some points. So startup time, it can be a lot quicker with the newer generation solid oxide fuel cells, for example, metal-supported solid oxide fuel cells.
Okay.
Now, the metal support, it doesn't agree very well with high sintering temperatures. So what you need is a ceramic powder which tends to have a lower sintering temperature than comparable powders. Mm-hmm. And again, this is a parameter which relates to our technology, because we produce powders in a very short thermal process, so they leave the process with a very high sintering activity and allow for a lower temperature and a shorter sintering time. So this again enables then a cell technology, metal-supported cells, which enables devices such as APUs, which can cycle up very rapidly.
I always think back in time here. I've been here for 17 years. We used to have a solid oxide fuel cell parked over there. It was about the size of a truck. I'm not being ironic here. It's a very functional device, very efficient, but the efficiency is only laudable if you think of combined heat and power. That is, the high operating temperature doesn't matter because you're recuperating that heat and using it, so it's part of the resource you're actually accessing there. But it was a very clunky device. Of course, it liked to be operated continuously. And that seems to me the one large difference, generally speaking, between the PEM cell and the solid oxide fuel cell because of the operating temperatures. When you lower them, it sounds like you're entering the market typically associated with the PEM cell technologies. That is, mobile, quick startup, you can shut it off. You're entering into a market that has been traditionally associated with the PEM cell. Would you agree with that, or is it?
I think it really depends on the application and a very closer look at the applications. Mm-hmm. Now, fuel cells have traditionally been a very broad spectrum, and maybe even become broader over time with new developments. Now, what we see in the SOFC is that we come from very high operating temperatures, and that would have been the system which you saw 17 years ago, which probably operated at 1,000 degrees Celsius cell temperature. Yeah. Now, today You have next generations SOFC, which operate anywhere from 850 to 750. And the ability to build these was very much related to the accessibility of materials, to build the electrolytes, the cathodes, even the anodes for those cells. And that is even more so true for the next generation SOFC, even for beyond state-of-the-art solid oxide fuel cell technologies. So we see ourselves, again, very much of an enabler of such developments, because it's quite easy to mix small amounts of powders in a laboratory, and that is what is quite often done at an early stage, an early R&D stage. But even as a next stage, where you would like to build a prototype, a demonstrator, you need larger amounts of powder. So you need to upscale from this laboratory level to a pilot production level, and then even beyond that to industrial supply. So I had already described a bit how we came from R&D markets to standard materials, to state-of-the-art materials, which we today produce in somewhat larger quantities. Mm-hmm. And then to not only enable the development and demonstration of such units, but then also the further commercialization. Mm-hmm. We can upscale our process in exactly the right requirements, and also see ourselves then very much as even the third stage supplier that can ensure a continuous supply of these very special, very novel materials, which are not to be found anywhere else in the market, coming from, I would say, competent company that has a quality management system, that has redundant equipment to ensure supply, and that is a professional supplier of industrial amounts of powder.
Do you like to attract and work with fuel cell stack manufacturers directly? Do you like to get involved, partnering? Do you invite them to come and work with you on future technologies?
That is our daily business. That's also why we are here, to really meet our existing partners, meet future partners. Mm-hmm. And it is exactly this dialogue which makes us tick, which makes us perform as a company. Because that's where we get our input, what is required from us, what enables our partners to go to the next level in their production activity, and also not only on the pure technology, but also the entire package out of continuous supply, of logistics, of quality assurance, and last but not least, the competitive cost. That not only allows you to present the technology, but also to make it commercially viable in the market.
You mentioned already the auxiliary power units as in a truck, for example, as a potential market. Of course, by comparison with the PEM cell, the glory of the solid oxide fuel cells is they're really not fussy about what they eat. They can digest just about any hydrocarbon, and they're happy to run on that. Does your technology have any effect on the fuels used in the system, or is it still indifferent to whatever broad range of typical fuels that you can use with a solid oxide fuel cell system?
It is again a point where we can help the people, mm-hmm. where we can help the stack manufacturers. If you take mobile units, diesel applications, sulfur always is a problem. So the challenge is to develop cathode materials that can actually tolerate a certain amount of sulfur, at least, or that can be regenerated at certain cycles when operated on sulfuric fuels. And this requires then novel materials. It requires developments on the material side to synthesize these durable materials under certain conditions. Mm-hmm. And this is something where our flexible process technology, where we can really pick elements from the periodic table and combine them according to requirements in the complex oxide, which then may have this function.
You've got a broad involvement and investment in ceramic technology, so I don't want to leave out other aspects of your company. Perhaps you could tell us about other ceramic products that you're working on.
Thank you very much for that question. The SOFC, it's a very important market for us. Another very important market where we also see our synthesis technology, spray pyrolysis, as very relevant is piezo ceramics. Now, piezo ceramics, you find those in many applications, in cars, musical instruments, but 99% of those contain lead at the moment. So the chemical element lead, it's in principle not allowed by law to have it in there, but there are no viable alternatives on the market. So again, material requirements, material developments are required to enable well-performing, cost-competitive, lead-free piezo ceramic materials. And we even drive internally in our company a development project to develop those materials, and even in that case a bit more the process to also make piezo ceramic objects out of those materials. And there we are in the fortunate position that last year we were even able to secure a Norwegian grant funding from Innovation Norway for a 3-year project to make these developments and prove the spray pyrolysis technology as a powder production route for piezo ceramics.
We're almost running out of time here, but if you would try to look forward into the crystal ball and imagine you're coming back 2 years later to hold the same conversation, what would you have to say?
That'll be interesting then to compare in 2 years. We'll have to do that on YouTube. But what I would definitely see is that those 3 steps which we have taken, R&D supply, more standard materials, and now industrial supply, that we really have established ourselves as industrial supplier, that we have expanded our facility and our processes and really gained a solid foothold in that market.
Great. Well, we certainly wish you all the best, and I'm looking forward to having this conversation again in 2 years.
Yes, same here.
I've been talking to Andreas Richter, who's Sales and Marketing Manager at CerPoTech, well, we look forward to seeing you again. For further questions, and there are technical details, visit the booth at B60, and there, this genius can go into the technical side, which certainly is beyond my forte. Thank you very much, Andreas.
Thank you very much, Brian. Thank you.
And thank you. Up next on stage is a phenomenal podium discussion. It'll be very interesting on the international partnership for hydrogen and fuel cells in the economy, and we will have government views. These are the makers and shakers of our environment, so it's worth a listen. Join us.